Hey everybody, so in today's workout, I will be discussing how exercise intensity influences acid-base balance, fatigue, and the body's long-term regulation of pH. Now, exercise places a stress on multiple physiological systems, and one of the body's major goals is maintaining homeostasis despite metabolic demands. Now, as I'm doing these single leg sit-to-stands, ATP demand increases and hydrogen ions begin accumulating as metabolism accelerates. Now, at lower exercise intensities, the body's buffering system and transport mechanisms are generally able to keep pace with hydrogen ion production. However, as exercise intensity increases, hydrogen ions may begin accumulating faster than they can be buffered or removed. This causes the body's pH to decrease, making the environment inside skeletal muscle more acidic. And although fatigue is influenced by many different factors, increased hydrogen ion concentration can interfere with muscle function by reducing enzyme activity and altering calcium's role in muscle contraction. These changes contribute to a decline in force production and during prolonged or high intensity exercises. Now, my intensities exercising here are some wall sits. So my body, continues relying on multiple systems to regulate pH. Now, while respiratory system helps remove carbon dioxide and buffering systems resist changes in pH, another organ also contributes to long-term acid-base regulation. The kidneys play an important role by regulating hydrogen ion excretion and bicarbonate conservation. Now, although kidney responses occur much more slowly than respiratory responses, they are essential for maintaining acid-base balance over longer periods of times. This demonstrates that maintaining pH is not the responsibility of a single organ system. Instead, multiple physiological systems work together in order to preserve homeostasis. Now, this is my go-to exercise here for demonstrating a recovery exercise, but walking recovery I'm transitioning into right now. Hydrogen ion production will decrease. My breathing will gradually slow, and the body's regulatory systems continue restoring normal physiological conditions. Recovery allows buffering systems, the respiratory system, and the kidneys to continue regulating pH until homeostasis is restored. Now, understanding these responses helps us explain why recovery is just as important as the exercise itself. So in conclusion, summarizing everything up, increasing exercise intensity places greater demands on acid-base regulation. Buffering systems, transport proteins, and respiratory systems, as well as the kidneys, all work together to regulate hydrogen ion concentration and maintain pH. And these physiological responses allow exercise to continue while helping delay fatigue.